This is recording.
RTI
International
Center for
Forensic
Science
presents
Just Science.
Welcome to Just Science, a podcast for forensic science professionals and anyone who is interested in learning more about how real crime laboratories work. In episode 5 of the 2019 R&D season, Just Science interviews Dr. Rebecca Wagner, a researcher at the Virginia Department of Forensic Sciences in Richmond, about a comparison of two validated LCMS methods for the quantitative analysis of opioids, cocaine, and cocaine metabolites in biological matrices. The state of Virginia is not immune to the current opioids epidemic. Since 2012, the Virginia DFS has seen a 191% increase in the number of reported opioids results and a 1,439% increase in the number of reported fentanyl results for death investigations. With these emerging drug trends on the rise, the DFS is searching for new ways to improve DUI and post-mortem toxicological screening. Listen in as Dr. Wagner discusses confirmation testing, sample conservation, and the development of new analytical methods in this episode of Just Science. If you are interested in emerging drug topics, please visit forensiccoe.org to learn more about the upcoming NIJ policy and practice forum being held in D.C. The forum will build off the momentum of the widespread stakeholder meetings convened to discuss the drug threats and the consequences of this national epidemic on the public safety and health and the criminal justice response. This season is funded by the National Institute of Justice's Forensic Technology Center of Excellence. Here's your host, Dr. John Morgan.
and welcome to Just Science, the podcast for forensic science professionals. I'm your host, John Morgan, with RTI International's Forensic Technology Center of Excellence, a program of the National Institute of Justice. Today we are at the annual meeting of the American Academy of Forensic Sciences in 2019 with Dr. Rebecca Wagner, who goes by Becky. And Becky is employed by the Virginia Department of Forensic Sciences in their Richmond laboratory. She has a PhD from Duquesne University in analytical chemistry. She works in toxicology, controlled substances, and trace evidence. She's an affiliate member of the Organization of Scientific Area Committees and has co-chaired several workshops on uncertainty of measurement and method development for both regional and national forums, and a member of the Society of Forensic Toxicology. So you all in DFS, like a lot of laboratories, have had a pretty huge run-up in the amount of novel psychoactive substance work that you're having, both on the controlled substance and tox side.
Yes, we have both the novel psychoactive substances as well as the opioids with the fentanyl derivatives in both controlled substances and toxicology.
And you all in DFS actually do post-mortem work as well?
Yeah, so our toxicology section is a pretty unique section. We do both driving under the influence of alcohol or drugs and then also post-mortem toxicology.
Okay.
So we have a wide range of samples that we may receive within the laboratory and also very different concentrations, which makes the toxicology analysis difficult at times.
Sure. Well, it is unusual because most medical examiner offices will have a tox section inside them, but they send you the samples is what they do.
Within our same buildings, we have medical examiner offices, but they are actually separate from our agency itself, and they will submit their evidence to us, and then they request what analysis is done, and then we perform the analyses and send them the report. So they are considered one of our customers.
So you started in DFS in 2012, is that right?
Yes, that's correct.
And you all, since that time, 191% increase in number of reported opioid results and 1,439% increase in the number of reported fentanyl results for death investigation cases.
We've had a significant increase within our laboratory since then, and that was pre-opioid crisis, and then now since we are in that opioid crisis, we are seeing so many different drugs and combinations of fentanyl derivatives as well from that opioid crisis, which makes method development and validation challenging too because the compounds are always changing. So our method development and validation is always changing as well. And we have to stay cutting edge, but we also have to validate to some sort of standard so that we know the method is robust and is producing accurate results.
This is interesting because I don't get to talk to people who do both the DUI kind of stuff and the post-mortem. So are your methods different between the two sides of that? I mean, how do you differentiate them at all?
We do not actually differentiate them at all whenever we're doing the analysis. In toxicology, we do batch analysis. And so we do not work, a case is not worked from the beginning to finish by one examiner, which is a common practice in toxicology where the multiple cases that may need THC analysis all go into one batch and are analyzed at one time. It helps with the efficiency within the laboratory, given that most cases are going to need multiple different methods to analyze and completely characterize one case. So it does make it challenging, but what we have to do for efficiency is try to develop one method to analyze for all case types. So we're not splitting our laboratory to a driving case versus a postmortem case. They can get analyzed within the same batch run. So our dynamic ranges for our concentrations that we have to evaluate have to be pretty large to encompass subtherapeutic concentrations for drivers or even therapeutic concentrations all the way up to anything that's going to be like a toxic concentration in an overdose type situation.
Sure. So are you doing any kind of screening or presumptive testing before you do the confirmatory?
Yes, so our laboratory is currently doing screening by immunoassay, which is a very non-specific technique and can give us some information on what drug class may or may not be present, but is heavily reliable on the cross-reactivity, which can make it a little bit challenging. One of the really cool projects that we're working on right now is a screening method that's a little bit more comprehensive using quadruple time-of-flight mass spectrometry that is going to be able to look at, it's still a targeted method that we're working on right now in this phase, but targeted in the aspect of we have over 265 compounds within that method to analyze simultaneously at one time. So we have our current ELISA testing, our immunoassay, but then someday we'll have our QTOF method online,
Sure.
which will give us a little bit more information about what actual drug is present, and then we go on for confirmation testing and quantitative analysis.
Yeah, we keep a QTOF actually two QTOFs in our research laboratory, and they're really great because they'll show you everything. There's a big data problem that arises, I'm sure, when you're actually doing it in a production laboratory like what you're doing.
Yes, so there are a lot of challenges that are presented. It's a very powerful tool, and it's a powerful tool that's been used in research for a long time. It's not a very new technique. It's newer to forensic toxicology, but the data analysis or the extraction and preparing the sample is kind of the same in routine. Put it on the instrument, analyze your sample, but then the data processing on the back end can really be where the struggles kind of incur because there's just so much data and so much information where an immunoassay type technique, it's pretty simplistic and the reporting is pretty easy and can be done quickly.
Ultimately, when you have the QTOF up and running, you're still anticipating that LC tandem mass spec will be your workhorse for confirmatory analysis.
Yes, most of our confirmatory analysis, we've been shifting to that LC tandem mass spec. So our triple quads, we have several across the state. And it's...
So you're still using triple quad as
yes.
your confirmatory right now?
Yes, our confirmatory and quantitative methods are all on triple quads. From what we've been working on since I have started, we're not really doing as much GCMS quantitative testing. We still have methods that we have not shifted over and methods that may just still perform better with a GCMS as opposed to a triple quad. But all of the methods that I've developed since I've started in toxicology have all been triple quad methods.
Okay, taking a step back a little bit. At some point since 2012, you all decided, oh my gosh, we're seeing a lot of not only fentanyl, we're getting some fentanyl analog materials, and you felt there to be a need to have some new methods that were a little bit more efficient than what we've had in the past. Now, efficiency is a couple of different things, right? Efficiency can be like just getting the casework out the door, but it also can be with respect to things like recovery. Some of these assays need to be fairly sensitive, and there are new methods for doing sample prep. So tell me about your thought process there. I mean, how did you decide you were going to do a new method, and how did you choose the methods that you were going to be doing?
So whenever I first started, our laboratory had two methods that were in development, and our triple quads were actually not online yet whenever I had first started for casework.
Okay.
They were still working on the development validation side of the house with those instrumentation. One of them was benzodiazepine method, and the other one was for THC analysis. So those were the two methods whenever I had started that were in the works that we kind of carried through and put our triple quads online. Some of those we needed to expand our testing panels for our benzodiazepines, or even methods that, sometimes have some certain struggles. Like we all know THC, and it can be a very hard compound to be able to analyze and a little bit persnickety at times. So what we kind of do is we kind of look at what our need really is. So we really wanted to make robust methods and transfer them to our triple quads. The one thing that's kind of unique about my position is I don't actually do casework. So I am just research and development.
Wow, that's quite the luxury. I don't know how many labs actually keep somebody to do that work.
I'm kind of a unicorn. In some aspects, a lot of people would like to have a position like mine in their laboratory, and it's really shown to be able to have a significant impact on the toxicology section, or even, like we had mentioned earlier, trace evidence as well, because it's very hard to be able to dedicate time to do the research and develop robust methods while working casework, because casework is always a number one priority and the backlog is a real problem. So it takes a lot longer to get methods online. So since I started, we've been able to get a lot of methods online and kind of expand our testing with some anti-epileptic drugs that we were unable to test for or did not test for previously. And some people may wonder why you would test for anti-epileptic drugs. Part of that is compliance with post-mortem cases, and was the person taking their medicine, or was the caregiver administering the medication as needed? So we do have some of those instances where compliance can be an important part of our testing as well. But then back to our opioid crisis, we see a lot of mixes of drugs. So our thought process in laboratory efficiency, typically laboratories are going to do a benzodiazepine analysis, a cannabinoid analysis by drug class, as opposed to combining things that they typically see together, opioids and cocaine.
Sure.
Why would we want to do two separate methods, have to use two separate aliquots of blood, consume more of our sample, take double the amount of time if we can combine those together?
Well, yeah, and it makes some sense. I know that we talk a lot about the opioid epidemic, but I think a majority of cases are polydrug. I mean, yeah, so at least on the death side. I don't know whether you're seeing that on the DUI side. You probably have some interesting data in that regard, too. Are you seeing a lot of polydrug stuff on the DUI side?
We kind of see it across the board, and it really depends. And our concentrations can be very different that we're seeing. So when it comes to a laboratory taking that time to combine a method, we also have to think about our concentrations that we're going to see and the concentrations of those compounds. For a fentanyl, we need to reach a much lower limit of detection as opposed to potentially a cocaine that could be a higher concentration, or a methadone that's going to be a higher concentration. That can be a challenge with developing your analytical technique, and your sample preparation is kind of finding that happy medium so that you're not overloading your detector, but you're also meeting the limits of detection for our lower concentrations that we do need to reach. So with our opioid cocaine method that we developed, we actually have 3 different dynamic ranges within one method. So it doesn't necessarily make the analysis any different, but the preparation of your calibrators and controls, the solutions are more complex because there are more compounds at different concentrations. But once you get that initial first step done, the sample preparation is all the same. The extraction is the same.
Sure.
No matter what drugs we have in there, and then the instrumental analysis is the same. So we can really hone in on efficiency and saving some of our sample that it's not getting consumed at such a rapid rate.
Are you all collecting some of this data, aggregating it for surveillance methods or anything of that nature?
Within my tenure at the department, we have started collecting data from 2012 onward, and every calendar year we take a survey of all of the compounds reported within that year and the concentrations as well. And we are able to tabulate that and put it into charts, tables, whatever we may need. One, to look at kind of the overall trends as to what's increasing, what's decreasing over the years, and be able to use that as well to help us determine where we need to focus our efforts on.
Let's focus in now on the particular project that you're doing in terms of the method. So one is solid phase extraction, based on solid phase extraction, which actually has come a long way. I mean, there's a lot of new commercially available approaches now that forensic science hasn't necessarily used very much of. How does solid phase extraction work in practice, and how do you do that method?
So with our solid phase extraction, it's a little bit more time consuming. Our laboratory, and like you said, most laboratories don't have full automation within their protocols. So we do a positive pressure solid phase extraction. Some laboratories may use a vacuum manifold still, but we're able to hold 48 solid phase extraction columns within one analysis. So we can analyze 48 samples, that's including calibrators and controls, so not 48 case samples at one time, which helps as opposed to kind of our glass chamber vacuum manifolds that don't hold nearly as many samples. The one problem with the solid phase extraction is that we do need an analyst there the entire time that solid phase is occurring. So, you condition your column. So you have to add your solvents to be able to condition your column and get your column ready for the sample. There is some preparation required of that sample as well. Given the uniqueness of our laboratory being both antemortem and postmortem, our postmortem cases, sometimes that blood is not really looking like blood, and it may have some chunks or particulate matter in it. So we actually dilute our blood prior to the addition to the solid phase extraction column, and we'll centrifuge it to help take out some of that particulate matter so it doesn't clog our solid phase extraction column.
Sure.
That will be one of our biggest problems that we can't control.
I assume also one of the other problems with postmortem is that you might have carryover effects and that kind of thing. So you have to be careful with that column conditioning when you're doing such a wide variety.
Yeah, so with the solid phase, we don't have as much carryover concerns as what toxicology fears as the carryover, as the instrumental carryover is really our biggest concern. But sometimes you'll see with our solid phase extraction, some samples will kind of elute at a slightly faster rate than others if they're a little bit thicker or more viscous of a sample type. So that's one challenge that the examiner has to face, is trying to keep everything eluting at a consistent rate for all 48 samples that we're trying to do our solid phase extraction on at one time.
The other method is not one that I've been familiar with before, and that's protein precipitation. So how does protein precipitation work? I don't know that at all.
So it's actually really an easy technique, and our protein precipitation method that we developed is what we're using currently on casework because it is much more efficient than an examiner sitting and doing a solid phase extraction. It's as simple as taking the 1 milliliter aliquot of your case sample, adding 2 mils of acetonitrile and vortexing. During that vortexing, you're going to precipitate out any proteins. So you're going to have kind of like a chunky little bottom of what looks like a blood pellet that's kind of created into little chunks. But our compounds are in our acetonitrile, essentially extracted in an easier way into the acetonitrile.
Did you do efficiency studies on that? I mean, do you have data on that?
So whenever we do our validations, we look at the recovery and we spike our samples into the blood and we see how much we can then obtain back out of our blood. And so we look at that for both of our methods in our comparison, so the protein precipitation and then the solid phase extraction, to see which one has the best recovery. But the beauty about any of the methods that we develop, even if we have a 50% recovery, our instrumentation is so sensitive these days that as long as we're meeting our limits of detection that we need, even if we have a 50% recovery rate on our extraction, will hurt us that significantly in the end. But the one thing with the protein precipitation is it's simplistic, but it can be a little bit dirty in the extraction type. So you can potentially have more matrix within that acetonitrile layer. So the one unique thing that we did with this method, after we did our protein precipitation, we put our samples in the freezer once they're centrifuged and really separated, and we kind of, in a way, froze the samples. The acetonitrile never really freezes.
Okay.
But you can see 3 distinct layers. You have your pellet down at the bottom, and then you'll have another layer that starts appearing after about 15 to 20 minutes. You can see a layer that looks a little bit dirtier, like more blood-like, that there's some particulates within that layer, and then there's a top layer that's actually very clear. And we found that by doing a comparison study of taking the entire layer, including those 2 top layers, versus taking the very uppermost layer, that uppermost layer is clean. It gives us actually the same detection as taking the whole supernatant, because we don't have as much suppression with having other matrix within that sample. So it helps save us in the long run on our instrumentation as well, because we're not putting as much stuff and matrix into our instrument. So it helps keep them a little bit cleaner as well.
Yeah, and that's a big deal.
Yes.
You use a fair amount of staff time on that,
Yes.
downtime on that. So you actually did some follow-up validation of both methods in the laboratory to actually get these into practice, which I think is fascinating. I don't think we do enough, and I really appreciate the fact that you're here at AFS, that you're presenting the material and that kind of thing, because I don't think we do enough of sharing validation methods across the community.
Yes, so we do pretty extensive validations, especially given our unique situation with the antemortem and postmortem case types. We look at a lot of different matrices, so it can actually help the community in many aspects, that if they are just an antemortem laboratory, we do fully validate to an antemortem case type, but then we also have the medical examiner case types, which would include postmortem blood, liver, urine, and different matrices that we may see within that realm of our laboratory.
So now in the abstract, it talks mostly about blood and urine. You're doing postmortem, I assume there's vitreous fluid and other things like that, but you're really focusing in on blood and urine here.
Mostly blood, urine, and liver are the samples that we can most easily obtain. The one challenge that you have, you mentioned vitreous, and you don't get very much vitreous. It's just the nature of the beast. So, and it's hard to obtain samples of vitreous that usually if we have samples submitted from our medical examiners and they're doing analysis with vitreous, they're going to consume all of the sample, and there's not going to be enough quantity to what we really need to perform a full validation on that matrix type. So there are some challenges in the postmortem realm. Another challenge that many laboratories have, especially ones like us that we are not directly associated with our medical examiner's office, is the samples that are submitted from our medical examiner's office get returned to them.
Sure.
So obtaining a plethora of different matrices can also be sometimes challenging, and a lot of laboratories do have that challenge of being able to obtain these alternative matrices and those sources to be able to fully validate.
Well, yeah, and I suppose I hadn't really thought about it from this perspective. I know when like DNA people complain about the police investigators all the time. It's just like they're just throwing samples into the laboratory. You know, if you're taking too many samples off a particular case, and it can be overwhelming if they thought through which samples are truly probative or not. But I guess it's true on the medical examiner side for you all as well, right? Are they necessarily choosing wisely with respect to what they need to have actually analyzed?
I think it depends on the medical examiner themselves as to what type of testing they want and what their goal is and what that particular case has. I mean, naturally, our number one is going to be we're going to have antemortem blood.
Right.
And typically, we don't receive very many liver samples. Usually, it will be a combination of blood and liver.
Mm-hmm.
And we don't necessarily have to go to a liver testing if we have the testing and it's capable of being tested in blood.
Sure.
We don't have to go test in every single matrix.
So your validation was extensive, and I'm not going to quiz you on it because it's quite the list. So validation included accuracy and precision, sensitivity, calibration model, ionization, suppression, enhancement, recovery, carryover, of course, interferences, dilution integrity, and post-extraction stability. So that is a pretty extensive validation, but I think that's pretty reasonable, actually, given the fact that, what you're trying to do in the tox laboratory.
I don't know if you're familiar with the SWIG tox validation guidelines, method development and validation guidelines that the scientific working group has developed. A lot of those things, with the exception of recovery, is addressed within those guidelines. So we try to follow those guidelines within our laboratory and sometimes go above and beyond what may or may not be suggested within those guidelines to help give us that robust testing scheme.
And you compared the two, and you already gave away the answer, right? And that is that protein precipitation turned out to be not only less labor intensive, but also more effective across both blood and urine, or am I getting that wrong?
So the protein precipitation is much more efficient. Both of our methods pass the validation to the same extent. We had some difficulties with urine samples with accuracy and precision for both sample preparation techniques.
Sure.
The solid phase extraction was slightly more accurate than the protein precipitation, but it was still outside of our predetermined acceptance criteria. So whenever we create a method, I will write a method development summary. That method development summary will explain everything, the good, the bad, the ugly of that method that we've created. And this gives kind of a story in a document to say, hey, did we try this? Hey, did you try that? And it kind of summarizes what was tried and what did work. Then we write a validation plan. That validation plan will delineate whatever acceptance criteria and experiments are going to be performed. So accuracy and precision, we predefine that we have to have accuracy and precision within plus or minus 20% of the target concentration. Then once that plan is approved within our agency, we will then go on to the validation, and then we'll write a summary. That summary will include all of the information. So with our urine analysis, we did not meet our predetermined acceptance criteria for accuracy and precision for either of the methods. Now, our laboratory does not currently report out quantitative results for urine. We are presence only for urine samples. So one thing that we found with that protein precipitation method was that the concentration of creatinine within the urine was actually causing an effect on our analysis, with both the amount of suppression that we were seeing and then also with retention time shifting. Sure. For our early eluting compounds. Creatinine comes out in a really big blob early on in our analysis, and morphine, hydromorphone, and oxymorphone come out within the first 2 minutes. And you can see that effect of that creatinine coming out with slight retention time shifting. And it's really dependent on the sample of urine, how much creatinine's in that sample.
Yeah, it's generally a marker of dehydration in the individual.
We did try to do some dilutions with the urine to kind of solve our problem, and it really just didn't meet the mark for us. And then the other thing that when you talk about urine analysis, especially urine quantitative analysis, oftentimes the concentrations are much higher.
Right.
So, you start to ask the question, is the dynamic range that we've developed is mainly for blood.
Right.
Would that dynamic range actually apply to what we would be seeing in urine as well? So does it really warrant its own unique method?
Sure.
But the presence of that compound in the urine can be sometimes sufficient, especially if you also have the blood analysis along with it.
Sure. Is it presence with a cutoff? I mean, do you have a cutoff concentration below which you say that's not necessarily present as well? Because that could also be an issue with your accuracy and precision thing, right?
So with a lot of our methods that we're developing now, we do have a low threshold concentration in which we validate to say anything less than that low threshold concentration we do not report out a value or a presence of in the qualitative realm. So we do try to define what our lower limits are, whether they're administratively set or from instrumental limits of detection.
So where are you all sitting right now? Have you actually transitioned the protein precipitation method into practice now?
So we have actually been using the protein precipitation method for probably almost 2 years now.
Okay.
We've added to that method since then to help with our need for our opioid crisis and the fentanyl derivatives.
Sure.
So we've kind of developed an addition to our method to analyze for 34 different fentanyl derivatives as well within the same analytical method.
Now, of course, a lot of that's evolving with the changes in DEA regulating and scheduling the derivatives. It seems like everyone's going back to just plain old fentanyl now. Are you all still seeing a lot of the analogs?
We have actually been doing tracking in our controlled substances section as well as our toxicology section to see what compounds we're actually seeing and what compounds have kind of faded off over time. Our toxicology fentanyl derivative method has been online for a year now. And controlled substances has been tracking their compounds for several years. And we seem to see a consistent grouping of compounds. Whether or not it's really dying off, it doesn't really appear to be kind of tapering. We don't necessarily, in our toxicology section, always perform our fentanyl derivative analysis as well.
Sure.
So it's not every case gets fentanyl derivatives. Sometimes it's harder to be able to really detect full trends if not every single case is getting every single testing.
So in your talk yesterday was actually recorded at the NIJ Research and Development Symposium here yesterday at AFS. And so it will be available at the time this podcast is released for archival viewing. So everyone will be able to access your presentation yesterday. So did that have the complete examination of your method and the validations associated with it? Or are you all also looking at maybe publishing some of the material around this in a journal?
Yes, so we have multiple different avenues to actually obtain our methods as well. So the presentation has kind of a synopsis. Since it was only a 20-minute presentation, we could not present all of the data since it's so extensive for both methods.
Sure.
And then the addition of the fentanyl derivatives. But we have all of our procedures online on our website. And with that, it's free public access to everybody, so they can at least see our procedures manuals and see what we have in production currently within our laboratory, which can be a great resource to a lot of people. We're also working on some publications to have those submitted as well, to have those out in peer-reviewed form.
It's really amazing that DFS has chosen to invest in that kind of research and being able to build these new methods for not only Virginia, but for the entire community.
It's a great opportunity, especially since our laboratory is a very unique laboratory in that we do have a research and development section that's just dedicated to research and development and doesn't have to do and worry about the pressures of the casework on top of it. And with that, it allows us to be able to mentor students and also sit on their graduate committees to help further along in a sense, the youth to be able to see what it's really like to be in the laboratory, and having that exposure can be really important to help mentor people and be able to have them decide if this is what they really want to do for their career as well.
Sure. Well, this is fantastic. Thank you so much for being on Just Science today.
No, thank you for having me.
And we want to thank the National Institute of Justice for their support for not only the podcast and the Forensic Technology Center of Excellence, but also this kind of cutting-edge research that's of value to the entire community in forensic science. Thank you very much for listening.
Next week, Just Science interviews Dr. Jorn Yu about chemical analysis of controlled substances using automated headspace solid-phase microextraction. Opinions or points of views expressed in this podcast represent a consensus of the authors and do not necessarily represent the official position or policies of its funding.